Dear students, in the previous video, we saw that linear equations in two variables can be written in the form a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0. Now, if we find the ratio a1 upon a2, b1 upon b2 and c1 upon c2, there will be three cases. And what will be these three cases? The first case can be a1 upon a2 is not equal to b1 by b2. The second case can be a1 upon a2 is equal to b1 by b2 and it is also equal to c1 by c2. Third case, a1 by a2 is equal to b1 by b2 but not equal to c1 by c2. Now, if we see the first case, in this, the first ratio a1 by a2, which is the coefficient of x, and b1 by b2, which is the coefficient of y, both are the coefficients of x and y. They are not equal to each other. Whether they are equal to c1 by c2 or they are not equal to c1 by c2 doesn't matter. We will only check this case if we find the ratio unequal, then it leads to intersecting lines. Now, I'm just erasing this part so that it is clear to you. So, a1 upon a2 is not equal to b1 by b2. When this is the case, we have already discussed that it is intersecting lines. When a1 by a2 is equal to b1 by b2, then we have two cases. One can be that this ratio is also equal to the constant ratio c1 by c2. If it is equal to c1 by c2, then we get coincident lines. And when the ratio of a1 by a2 and b1 by b2 is not equal to c1 by c2, then we get parallel lines. Now you see that in intersecting lines, this is the case, there is a solution. When there are coincident lines, there is one line here and we definitely have another line which can be made here. So they have many solutions. So if intersecting lines are there or coincident lines are there, in these two cases, we call the equations consistent pair. Consistent pair of equations. And if we get the parallel lines, that means there is no solution at all. In such a case, the equations are called inconsistent.